Hello, myself Rishwanth Reddy. Today I'm going to present my final project of code ADTA 5550, which is of deep learning with big data. To start with, part one, use TensorFlow directly in coding. As the question indicates, is the student required to use TensorFlow directly in coding in this like homework assignment? Yeah, is true. As a component of this challenge, the development, training, and assessment of a conventional neural network, abbreviated as CNN, will be required. It is feasible that explanatory writing in TensorFlow may be necessary or recommended at some point in the future. TensorFlow is a well-known open source software package that may be used for the development of machine learning models such as CNNs. It comes with a comprehensive set of tools and packages that may be used for the building of models, training of models, and analyzing of models. In addition to its extensive use in commercial settings and academic research, a sizable number of experts in the area of machine learning utilize it is as a tool in their work on a regular basis. However, it is crucial to check the specific requirements and instructions of the assignments, or talk to our teacher or TA or our teacher Nguyen or TA to ensure if the use of TensorFlow or another tool is either needed or recommended. Checking the assignment's instructions or the assignment requirements are both good place to start if everyone want to do this. In a question 1.2, as mentioned, should the student use Keras in coding in this homework assignment or not? Yes, it is possible that the student will be able to use Keras to code. There is a design, train, and test CNN as part of project for this homework, but this will depend on the particular of the assignment as well as the structure of the assignment itself. For neural networks, Keras is an application programming interface that operates at a high level. Python was used in the development, and it is compatible with both TensorFlow and other base engines in its functionality. It makes the process of building, training, and assessing deep neural networks like CNN, which is convolutional neural networks, easier by giving a user interface that is more intuitive. Keras is a common tool for many people who work in the area of machine learning due to the fact that it is user-friendly, modular, and customizable. This is due to the broad use of Keras in research that is carried out in a variety of contexts, including academic and commercial institutions. Using this tool, developer will have an easier time fast prototyping neural network architectures and experimenting with a wide variety of model configurations, hyperparameters, and training methods. In addition, the tool will make the process of experimenting with different model configuration in a simpler way. In addition of these, it is recommended to go through the particular criteria and directions of the homework, or having the conversation with our professor or with a TA to ensure that the use of Keras or some other tool is necessary or encouraged. This may be done either by reading the assignment itself or by chatting with the instructor or TA. Checking through the assignment, homework assignment is one of way to accomplish this goal. As in part 2, it was asked that a dataset or images or audio files describing them. Here I used the dataset which I taken from Kaggle. The dataset is Airbnb new user bookings. It is the title of the project. Title of the dataset. As the introduction, the Airbnb dataset is taken from Kaggle. It is a bookings dataset that comprises information on the booking destination of new customers who are making their reservations using the Airbnb platform. The dataset uh, includes information on the user demographics, the destination of their bookings, and the date on which they made their very first booking. The information is used to make predictions about the user's initial booking destination. Um, as to describe this dataset, uh, here bookings made by the first time Airbnb guests, a website that is officially affiliated with Airbnb may be found at the given link here, and this is a screenshot uh, of the dataset where I took from, and here the data structure. The dataset comprises of 213451 rows and 12 columns in a total. Here is the sample table which includes all the variables. As of a full description of variables, here the ID describe user identification number which is exclusive to each individual user, and in second one, date account created is the date that account was first created, and next, timestamp first active, the timestamp of the user first activity, date first booking, the date of first booking that they made in their account, age, the age of the user, gender, the user's gender and range, the user's age range, sign up method, the user's preferred method of user registration, sign up flow. Here the sign up method, they can use a Facebook or basis, something, anything like that. And here sign up flow, the user's preferred method of user registration, language preferences. The users prefer language, it might be English, it might be French, it might be German, it might be Hindi, English, anything, just like that. Affiliated channel is another term for the user's own marketing channel. Okay. Affiliated provider is a marketing service that is provided to the user. First affiliated tracker is the user's initial point of contact with an affiliated marketing campaign. As I conclude, the data set the data set consists of a tough challenge to tackle as well as rich amount of data that can be used to investigate and build new methodologies and algorithms. The dataset is readily accessible to general public and may be obtained by visiting the Kaggle website properly. That's it of the dataset. In the part 3, we are going to know about obtaining Cypher10 dataset. As to go through clearly, it was agreed that The Cipher10 dataset should be used since it could be put to use in the creation, testing, and modification of models. This led to the decision. This collection consists of 60,000 color photos, each of which has a width and height of 6,000 pixels. There are 60,000 photographs that have been separated into 10 major groups. Following is a breakdown of how the 60,000 shot will be distributed. The remaining 10,000 will be examined, while the first 50,000 will be used for practice. Therefore, the first step in putting this information gained from the piece of art to good use is to acquire it. The Cipher10 dataset is located in the modules area, so let's go in that direction now. When we click on this link, we will be sent to a website that is hosted on Google Drive, and once there, we will be able to download the datasets. Once we have them, we can start GCP and learn the deep learning VM instances, which will be give us access to the Google Cloud Shell. Once we have them, we will be able to, once we are in the position of them, we shall be able to do so. Next, we will establish a new location under JPNTBK that will be referred to as Cipher10 data, and after that we will move all of the files from the database to the offsite virtual machine that we have already constructed. After that, the Jupyter notebook that have been installed on the virtual machine will be started, and at the point you will be able to continue working. Here is the screenshot I am attaching that includes the data folder and JPNTBK folder, which was taken from the Jupyter notebook. Yeah, and as continue here in the fourth part. As to continue in the fourth part, we will going to build, train, and test CNN on Cipher10 dataset. The design of CNN. Here in the convolution layer 1, the 2D data size is 32 into 32. Input shape is 32 into 32 into 3. Output shape is 32 into 32 into 64. And here filter kernel or window size is 5 into 5. Filter shape, weight shape is 55332. Stride is 1. Stride shape is 1111. Dimension. Padding is same. Activation function layer RELU. RULU layer 1. No filter. Input shape here is 32 into 32 into 3. Output shape is 32 into 32 into 64. The pooling layer 1. Pooling method is max pooling. Filter is 2 into 2. Filter here is window shape is 5 5 32 64. Stride is 2. Stride shape is 1 2.21. Padding same. Input channels 32 inputs. Input shape 32 into 32 into 3. Output channel 64 outputs. Output shape is 32 into 32 into 64. We can observe the architecture of CNN here. In starting, we can observe input image and then convolution layer, then pooling layer, then convolution layer, yeah, and pooling layer. And this is feature extraction, and in the next step we can do feature classification. Here we can observe um,